I think we evolved making a whole lot more Urolithin A, and that our guts have just been damaged.
We can't fight aging. We can age gracefully, eating better, doing exercise, not sitting in the sofa all the day, and have interaction with people for mental health also, so many things that link together.
Sedentary adults with only, so they're not exercising. The only intervention is Urolithin A, and you've increased their ability to utilize oxygen. And I mean, that is mechanistically linked, right? From the micro to macro. Hi, listeners. It's hard to believe, but New Frontiers in Functional Medicine has been going strong since 2015. With over 200 episodes and over 2 million listens, we are growing every year. My goal is to continue to bring you the best minds in functional medicine, epigenetics, and longevity. I want the content to be actionable for the functional medicine clinician and interesting for the rest of us. Thank you for supporting this podcast with your likes, with your honest reviews, with sharing the episodes with your friends and family. And if you haven't done so, please consider leaving a like or leaving us an honest review wherever you've accessed this podcast. Thank you, thank you, thank you to our sponsors. Because of our sponsors, these are companies that I trust, that we vet carefully, that we use in clinical practice, that I use personally. Because of them, everything associated with this podcast is free. If you haven't done so, I suggest you head over to drkffitzgerald.com to the podcast page where you can access the full transcript for every single one of these 200 episodes. And along with that transcript, you'll get an episode summary. You can get the research citations and additional content that is pertinent to the episode. I myself return to the transcript page all the time to pull out a little snippet of information that I want to recall or access a citation. Or better yet, sign up for our newsletter, again, at drkffitzgerald.com, and every single podcast episode will drop in your email as soon as it's released. Thanks again. Everybody, Timeline is offering an amazing promotion. So if you go over to timeline.com right now and use the code CARASKIN, you will get 10% off on your suite of products. And I'm really excited for you to try them. I love them. And, of course, I want to hear from you what you think. Hi, everybody. Welcome to New Frontiers in Functional Medicine, where we are interviewing the best minds in functional medicine. And of course, today is no exception. I am thrilled to be sitting next to Dr. Julie Faitg. She is a leading expert in mitochondrial research with over 9 years of experience focusing on muscle and brain biology, and recently expanding her expertise to include skin health. She's got a PhD in Translational and Clinical Research from the Wellcome Trust Centre for Mitochondrial Research. She collaborates with renowned scientists worldwide, including Nobel laureate Eric Kandel and other mitochondrial experts. Currently, Dr. Faitg serves as Senior Translational Scientist and Regulatory Affairs Lead at Timeline, where she makes significant contributions to research and development across various organ systems in the field of mitochondrial biology. Julie, welcome to New Frontiers. Listen,
thank you very much.
Yeah, absolutely. I have just had the best time talking with you off record. And I just want to say that you guys, she is a real mitochondrial scientist, like an in the trenches, hardcore, dyed in the wool expert in this arena. And we were having an interesting conversation about her backstory and finding Timeline. And I was asking her if she was excited about the Urolithin A molecule. And, anybody who's been with me for a while has heard me talk to Dr. Anurag Singh, and we've unpacked a lot of the science. And so she gave me this really cool story, Julie. I have to just share it, about how you heard Anurag present at a conference, and you guys immediately started dialoguing, and you began to ping him with different ways he needs to look at the data and, do the appropriate muscle biopsies and so on and so forth. But you were immediately excited about this molecule. Just, anything to add to that? It's just really fun to hear that.
this conferences is a tiny world also, and just looking at that and looking what Dr. Singh was like presenting, I was pinging like timeline all the time, like our president, like Chris Rich, and I was sending emails to all the people also in the company, and yeah, I mean, when like it's kind of the theme of your thesis and everything, and you like about so much this tiny mitochondria, so. Yeah, that's quite a nice story to talk about all the time. And that's the mitochondria world
Well,
also.
and right, and the fact that they actually listen to you, I find that
Yeah.
Anurag is really open to new ideas, and he's a curious mind. You guys are all a bunch of scientists wanting to ask the
Yeah.
questions and wanting to answer the questions. And I am always, I mean, I'm a huge fan. There's obviously I just am. I love working with you. I love learning from you guys, but
Yeah.
it's amazing what this molecule is and where it came from. And so we're going to talk about all of that. But before we do, let's just get into some background on aging. Like, what is aging? Give us
Yeah.
a little breakdown of the hallmarks of aging.
Yeah.
And then we'll move into where urolithin A sits in that
Yeah,
world.
for sure. So you learn, I mean, everyone knows here kind of the hallmark of aging, and aging is so complex. I mean, it's all the multifaceted process influenced by so many, I mean, various biological mechanism, definitely. And there's several theories that have been proposed over there, and including like 9 hallmarks of aging that I was published by I forgot Lopez Oden in
Yeah.
2016, and then they published another paper like in 2023, and
Mhm.
they have like 12 hour marks of aging. And the one that I like to focus about is for sure as a mitochondrial biologist, I will focus on mitochondrial dysfunction. And some people know that mitochondria is kind of the powerhouse of the cells. I like to call them our little battery, and they play such a crucial role into energy production and metabolism. And as we age, this mitochondrial function, because there's plenty of function. When we say function, it seems so simple, but it's not. There's calcium retention, there's ATP production, there's so many things, but also leading to when you have mitochondrial dysfunction, you have reduced energy for sure, and increase of reactive oxygen species. And so mitochondrial dysfunction has been linked also to so many various like age-related disorders. So this can cause so many damaged cellular component contributing to aging and age-related disease. So yeah, that's for me one of the key hallmarks. For sure, you have the gut microbiome, but when it's disrupted, I mean, definitely you don't have the microbiome is like disruptive. You have also the inflammation, chronic inflammation that has been added, because the 9 hallmarks of aging that have been cited before were maybe too vast, and now they're trying to specify them. And it's exactly what's happening with mitochondrial function. They try to really specific them because it's too large when you say dysfunction. Mitochondria could work from respiration, for example, producing energy also, but not working on the calcium retention. So there's so many different things that you need to be more specific. So that's why also this is really important. And also one of the key hallmark I think we need to talk is also the macroautophagy, when you
Mhm.
can find also the mitophagy. So you really want like autophagy is really eating the cells that is not working, like definitely. And mitophagy is essentially deleted the mitochondria that is not working. And when I mean with age, autophagy become really less efficient, exactly like mitophagy, and it's leading to accumulation of damaged protein or organelles. So that's one of the big hallmarks of aging, definitely.
Yeah, it's fascinating. So just being a mitochondrial scientist, you were but it's such a fundamental hallmark. You were
Yeah.
working in aging. Like you were,
Yeah, exactly. Exactly. Looking first of all on mice, also looking after that on human, and this is the consequences. It could be the cause. Sometimes you will hear a lot of scientists saying, "No, this is mitochondria is involved. This is when they're dysfunctional, they will do that." And some people said, "Yeah, but when you have, I mean, aging is linked to sedentarity, you're not moving, so." mitochondria will be influenced by your non-exercise life, non-activity. So they will be damaged. They will not be pushed to do something, because I like to call the mitochondria the good friends. They're everywhere. So basically, that's really important to look at them.
Yeah. We haven't had, I mean, we've had an okay toolkit, in functional medicine to, really support good mitochondrial function. But I know this is such next generation, the discovery, the ability to actually make urolithin A. And toxins, one of the things we always think about in functional medicine too is the toxic burden. Like acquired mitochondriopathy is something that we really see ubiquitously, be it like environmental toxins, or maybe it's an infection. Like we see this mitochondrial dysfunction in COVID, et cetera. So, it's just a huge fundamental player, not only in just aging, like health, aging, the changes that happen just with the aging phenomena, but the weight of all of the diseases and, toxic exposures and so forth.
Yeah, exactly. And you found mitochondria everywhere except in the blood cells.
Yeah.
And I mean, their main function, for sure, people would say it's produce energy, but not only, there's pattern of action of the mitochondria. So that's why I call it the good friend. Like, she's doing, she's doing quite everything. It's kind of my best friend, I like to call it like that. And it's really something, and that's why people need to be really specific looking at mitochondria, because there's many function, and yeah, when it's dysfunctional, you need to be really specific what is not working, and it will kind of give you the pathway of your research kind of, and what you need to look at.
Good for you. No doubt you nudged timeline and Anurag in that direction. I have no doubt you did. That's good for you. Good for you, Julie. I just want to throw out too, and then we're going to move in and do some work on talk about your newest research looking at the skin. But I just want to shout out on epigenetics as one of the hallmarks, because you guys, Urolithin A, and we'll link to this in the show notes, has been shown to favorably influence epigenetics. And that was my first the reason why I originally fell in love with your company is I knew urolithin A had to be an epinutrient, just by design of its sort of origin story. And so it's really cool that has come to pass, and you've demonstrated that, and you're publishing on that, and it's reversal of the bioage. So there's there's just so much it does. But let's talk about skin. Skin is always fun. Everybody's always into talking about, skin. And it's more than just how we look, although obviously everybody wants it to look great. It's where it's like aging kicks in there first. So, why are you guys investing in skin?
As a translational scientist, I like to remind people, skin health is not simply appearance, like you said, and it's high turnover organs. The body's largest organs. So, it's play a vital role when to maintain overall health. It's kind of the first warrior to fight for you, out there against all the environment problem, pollution, whatever. Skin is really the critical barrier, definitely, you have, and protecting, as I said, from different environmental issues like UV radiation, toxin, pathogens, but it's also protective on the compromise as we age. And so skin will lose some ability to regenerate and repair. So that's something you need to take care of. And I like to call it the 3 key pillars to support healthy skin. You need to nourish the skin and be resilient and really be careful to the skin, prevent and damage, because you need to protect your skin, and 3, regenerate and rejuvenate and repair the skin. So it's kind of the 3 angle that I like to call when I learn more about skins, because I'm from muscle, but every organ is really specific. But at the end, everyone wants the same thing in science, is to help age gracefully, because you don't want to look like just like you take an old skin. You don't want this old skin to become like an 18 young skin. You need to age gracefully and live with it. And it's just not only appearance, because you can use Botox, you can use whatever you want, but inside it will not fix everything. So that's why people need to realize, putting SPF, as an example, I was not putting SPF. I was doing a lot of swimming all my life. Since I was young, and I was not putting SPF at all. And now you realize what's the problem is. Even in winter, deep winter, raining, you put the SPF every day, you prevent your skin, you take care of your different organs like muscle, liver, spleen, whatever. You need to do the same for skin. It's the first kind of a nice friend for you to, yeah, to be there out there from the environmental insults, kind of.
Yeah, 100%. Yeah. It protects us from UV, protects us from
Yeah.
allergens, from toxicants, all sorts of stuff. And what's interesting to me when you were just talking, there was a kind of a cool study that came out, I think in 2015, looking at identifying that we can look at somebody and say, we can identify people who are aging
Yeah.
faster and people who are aging slower just by looking at their skin.
Yeah.
So that accelerated aging phenomena that might be happening on the skin is reflected inside as well,
Yeah.
as measured by biological aging. That's kind of it's an extraordinary window into what's going on inside. And so to
Oh,
your point, we want to take care of it. But yeah, go ahead.
no, no, exactly. And I mean, I think I will jump into, I mean, kind of a intrinsic aging and what we call extrinsic, like photo aging, kind of. And
Mhm.
intrinsic is really I mean, it's known as chronological aging, and it's really the natural process of your skin aging that occurs over time. And like gene mutation, as we said, epigenetic instability also, immune system deregulation, hereditary DNA damage, telomere shortening. This is kind of new things today.
Wow.
And importantly, like I said, mitochondrial dysfunction because of energy decline. There's reactive oxygen species productions. There's mutation. There's decline in mitochondrial turnover because there's not mitochondrial turnover. I mean, I like to call it quality control. I will maybe go more in detail after, but it's really important to look at the entire complex of the mitochondria. And there was a paper published in 2020, I think it was Oblong et al., something like that. They look at transcriptomic data regarding like fibroblasts of young and old people. And inside this biopsy, they saw that oxidative phosphorylation, so all related to respiration, they've I mean they shown that these genes were inhibited in dermis from the old donor. And so you can see that with aging, even in the skin, all the mitochondrial gene are just inhibited and decreasing the expression. So all the cellular energy decline with the oxidative because of the oxidative stress and all the key hallmark of aging features of intrinsic aging. And then you have the photo aging.
Before you go into photo
Yeah.
aging, I just want to put a pin in that for a second and underscore what you've said. So here in our skin, which we look at and
Yeah.
address or ignore, however it is that we're
Yeah.
choosing, maybe we're obsessive about it. Like I've always there's certain pieces that I'm like, I have this spot of nummular dermatitis that drive anyway. So our skin has all of these hallmarks that we just introduced, that you just introduced. All of that phenomena is occurring right there locally in our skin, causing the intrinsic aging phenomena. So that's a really important point I want to hit home for everybody to get.
Yeah.
And now,
No,
yeah, go ahead.
no, 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 I completely agree with you. Like, it's not all marks of aging appears for every organs, like in a similar way.
It's
It's not,
amazing.
yeah, it's not just we talk a lot for muscles and whole body, but it's specific exactly to all the organs. Everything's happened similarly, and all these hallmarks are all interconnected. That's why aging is a natural process. We can't fight aging. We can age gracefully by doing many more things that would be better, like eating better, doing exercise, not sitting in the sofa all the day, and have interaction with people for mental health also, so many things that link together.
Yeah, that was a little bit of an epiphany for me. Thank you for that. That's just really cool. So let's talk about photo aging.
Yeah, I mean, aging, like some people call it extrinsic aging. It's quite of a tricky word, like intrinsic, extrinsic. It seems like really like Hollywood films. You have, I mean, for sure, the UV light exposure, radiation lifestyles, cigarette smoking, like all smoking environment. And it's caused really by these external factors. And you will see that by the skin structure. You lose like elastin, you have the breakdown of collagen, which is more the inside. But overall, you have a result of a premature skin aging. You have deep wrinkles, you have some of a really important like enzyme was decreasing, but in terms of outside, you see really deep wrinkles. You see like uneven skin tone and chronic inflammation like redness and everything. So that's really looking, I mean, photo aging extrinsic is really from the outside, and when intrinsic is really from the inside. So that's really the main difference between the two skin aging type.
But if you're going to do a skin intervention, you're thinking about intrinsic and extrinsic together and making a difference, and with both. Now, okay, so then specifically, would we think about, like, I guess maybe with an eye towards your expertise and the urolithin A molecule, what are we thinking about as far as interventions that can actually, effectively address these two phenomena?
Yeah, for sure. I mean, there's a lot of promising and really current approach to counteract all this skin aging. I mean, we can talk about really quickly about retinol, which is the gold standard today. But it's essentially, I mean, affecting all the wrinkle from the outside, I will say, because it's not that optimal safety of the ingredient. We know that with retinol, we have a lot of irritation. So we need to use it carefully. But with UA, I mean, Mitochondria as a patent brand ingredient, we have this promising molecule to explore within inside and outside, because it's a postbiotic of the gut microbiome, and we have shown that is improved mitochondrial health and reduce age-associating like inflammation, and increase mitochondrial function, and also like all the muscle health. And so when we looked at it, we said, using that for the skin, that could be, because we have the curiosity and the passion for mitochondria and timeline. And so looking at muscle didn't stop here. And so the story of mitochondria is really something to explore. And it's still, we just know a little bit. And so topical application of UFRS represent really a compelling approach, I would say, to support all the skin health. Because when you think about skin health, you need to have a rejuvenate, you need from the inside to promote like collagen production, you need to promote elastin, you need to promote plumping, so many things. And we know that from the inside of the muscle that mitochondria produce a lot of things due to the quality control of the mitochondria. When you look at the life cycle of mitochondria, and you know that these really nice energy cells produce ATP. And so for your skin, you need energy. It's like the brain, it's like the muscles. So when we looked at the skin, and the first idea was like, we should do the same, because the longevity is not just like muscle, it's brain, it's skin, it's everything. And skin is the largest organ of the body. So why not do that? We know that urolithin, mitochondria is promoting the mitophagy of mitochondria, so recycling the mitochondria. I like to call it mitophagy like a Pac-Man. So, it's eating like all the bad mitochondria was not working. And UA is like, the teacher, and said, hey, you need to do your work properly, please, and boost him, and just giving like a boost of motivation. And I think it's kind of a nice visual to have. And so UA is really here to say to the Pac-Man, do your work. And so for that, after that, you have all the quality control is working properly. You have even new mitochondria is working, and it get rid of the bad mitochondria. So overall, you have a good energy production, and you have like efficient mitochondria for your skin. So that's why we think about that for the skin after the muscle, definitely.
Fascinating. It's really fascinating that you decided to jump into looking at skin. I just wanted to circle back a little bit to using retinols. I was sharing with you, I've talked about this on my podcast before. I had my own burn experience with it, and that was it. I was kind of one and done with it. It was sort of horrifying. And if I'm understanding correctly, it has the potential to perhaps make my skin look better. It could, pushing cell turnover. But in terms of what you've just outlined as this real correction or potential to reach both intrinsic and extrinsic pathways and correct the various facets of them that are disrupted during the aging journey, retinol is not doing any of that. Is that correct?
Yeah, I mean, definitely retinol today is really the gold standard. I would
Right.
not go
So we don't
against
want to,
that.
yeah, yeah, okay. I don't want to
But
insult retinol.
yeah, no, I'm a nice
But
friend.
what's it doing
Disagree.
mechanistically though? I'm curious, below the appearance, what is it doing mechanistically?
I mean, the retinol definitely is looking at wrinkles and also links sometimes at collagen production. Not all the study have been published, and it's also something that I found really lacking in this environment. Knowing that I was from brain and muscle,
Yes.
people obviously on all their website they said, "Oh, clinical results," but they do not publish all that. And I mean, at Timeline, we really want to have all the transparency. So that's why people can understand even better our compounds. And when we started with the compounds compared to retinol, we did the safety first, like looking at is this one will be like people will have reaction, sensitization, everything like that. And we found like after all the trials that would go maybe deeper after I mean, the results were just incredible because we have kind of a same exercise than retinol. Like mechanistically, they're not going in the same pathway. Like they into the skin. I think retinol is more about proliferation and just doing so many things, and UA is just helping the skin to repulp and be healthy. I mean, I'll see retinol to more correct and do the things like giving you a nice renewal skin renewal, definitely. But
Okay.
in terms of inside, I mean, I don't know the studies today, like what really retinol is doing in the inside, and
Mm,
that's why also it's lacking,
mm.
and it's need to care to use carefully, and also that's why also the concentration of retinol by different countries also decrease year after year. Like
Oh, really?
regularly, people saying, okay, now it's 0.3%, I think. And so,
Oh,
I'm even sure that it will decrease even more because of the sensitization. And I'm sure when you use retinol, your skin will also be more reactive year after year by using retinol. If you use other product, they may be more sensitive after that. That's a kind of an opinion that I have with retinol, but I think used in a proper way could be good, but I'm not sure it's doing really something deeper. It's more on the surface, definitely.
well, I hope that they hear you, the people that are, the companies that are producing it and consider engaging in some deeper research. I know you're bringing some, you're bringing some credibility to the industry that has been like super woefully, like, I don't know, uh, I don't know if regulated's the right word, but certainly there's been a real lack of commitment to good
Yeah.
science. It's like 6 weeks later, my skin looked younger,
Yeah.
and that's it. I mean, that's a piece. That's a piece. That's valuable, but you guys are doing so much more. And we're going to talk about that in a second, Julie, but I want to first ask you, or make any comments on that you want, but I want to ask you about Urolithin A discovery, just kind of the backstory for anybody who's listening, who doesn't happen to know. It's kind of a
Yeah.
cool molecule. So tell us about all
Yeah.
that.
So, I mean, it started like 15 years ago, like when they looked at the pomegranate and they thought about all the health benefit from the pomegranate. And when they looked at the pomegranate, they found that this molecule is produced after eating this pomegranate, the L-arginine inside. And so when you eat that, it's converted if you have the right microbiome and microbiota to convert the L-arginine into UA, into urolithin A. Interestingly, when we did a study, at least 30% in Europe, something like that, have the right microbiome to convert in urolithin A. In the US, maybe was 10 to 15%.
Not so good.
To some food. That was quite interesting, definitely. And so if you have the right microbiome, you produce the UA, and we have shown, I mean, it's a postbiotic, as I mentioned, and we have shown in so many clinical trials, and we did some really deep research into that to improve mitochondrial health and all the age-related associated like inflammaging. We improve muscle strength. I mean, there's many things we did into the muscle, and so this molecule, we were quite happy at the end to see all the results and also the feedback of the people. That's the main thing. Internally, we share all these results, like all the comment we have from them. It's just amazing. So to talk more about UA, what it's doing, as I said, is boosting the little Pac-Man, the little mitophagy to say to them, like to say to him, like, do the work and clean the cell, please. Clean the cell and bring more new mitochondria afterwards. So that's what UA is really doing, and helping the mitochondrial quality control to be on top of it, definitely.
I think we evolved making a whole lot more urolithin A, and that our guts have just been damaged. So I feel my little working hypothesis is that our cells were probably bathed in the information from urolithin A. Our mitochondria probably evolved like just sort of relying on it to help us. And then, over time, our microbiomes have profoundly changed, linking it back to like gut dysbiosis is one of the hallmarks, one of the recognized hallmarks now. Like,
Exactly.
not just urolithin A, we were, making a whole plethora of postbiotic compounds that, maybe you guys will tuck into later, but we're not anymore. And even when we are, like, I'm a proud card carrying urolithin A producer, but and I know Anurag Singh, he talks about how he doesn't make it.
I'm not a producer at all. A tiny bit, but not that much. And so it's so interesting to do the
but
test.
here's the thing. We're doing an NIH grant right now. It's funny. I was talking to somebody. I was just talking about this with my little group. Like, produce urolithin A, but I don't produce a therapeutic amount. I mean, that's the thing. I'm not making enough. So okay, it's cool that I've got like 6 of the microbes that will make it, but I don't have enough to actually make the difference that that I see when I take the product that you guys have created. So this is a really interesting thing. Probably it was an important player that we need abundance of, and we just don't have it.
Yeah, this is quite incredible. And I'm leading also the trial, like what we call the MitoPure Challenge. And I saw the results of the people who's taking it, and I've seen like someone have like 0 level of UA, and then with the MitoPure, I'm quite surprised, this is bring up to 200 or something. And that's really amazing. And people said, really, I produced that much with you? I was like, that's exactly why we did this molecule and what we put like into a supplement. And it's not like a supplement like so many things that you ingest and is not good. It's really something that is naturally produced by your microbiome if you have the right one, and it's something doing a natural job. So I think there's not bad thing about this one. So that's quite amazing, definitely, to see that.
Yeah, it's super cool. I just want to also circle back for a second. And you were alluding to not just doing all this research that you're so committed to, from preclinical to a plethora of clinical studies, but also just the anecdotal evidence of people using it. And I want to talk about the skin because there's some pretty cool science on the skin with urolithin A, but just anecdotally, you had told me off air that you've seen it, your family has really noticed it. And I thought it was kind of neat that your boyfriend, who's an Olympic athlete, he's a medaling Olympic athlete, can use it and actually see his recovery time improve.
Yeah, definitely. I mean, it's when I think Dr. Singh talked a lot about that. When you exercise, you have more mitochondria in your muscle because you need more. You have also more inflammation. That's where the natural inflammation is coming in. And so when you need the recovery, this is quite a really important period. And that's where for the athletes, that's where it's really the more important thing. I mean, the improvement of strength, endurance, which is amazing, but the main thing for the athlete is really the recovery. Because if your period of recovery is much better, for sure you can perform better. Yeah. And you feel better in your mental health also because you feel, I'm feeling good. I'm ready for tomorrow, tomorrow for the race. And it's so linked. I mean, the performance in the mind and the recovery in the muscle and everything. And when I was asking him, it's like, can you feel something? It was like, I think I sleep even better. And I think I don't have any like problem with my muscle after a huge training, and I'm feeling good. And I was like, okay, that's really interesting. So I was starting to say that too. I think it was the first year really when I arrived at Timeline. It's been 3 years now, but yeah, the first year and they, you welcoming and they bring you so many, like a nice pack of pills. And I was like giving that to him and it was worth it, definitely. I
That's pretty
mean,
cool. That's pretty cool. Are you guys doing any studies with athletes? I feel like you might have something going on,
yeah,
right?
so we finished one in Australia and the paper should be out soon. It was a
Okay.
really interesting paper with Lewis Burke over in Australia. So yeah, definitely. They presented already the results at some meeting, ACSM in the United States for sure, and it was really well received. And so the paper is nearly there. Just need to
Okay.
wait a bit.
Okay. Okay.
But no,
Well,
it's quite nice, really.
we'll keep everybody posted when it comes out.
Yeah.
We'll tell you about the findings.
Yeah.
I don't know what they are, and I'm excited to hear about them. Okay, so let's talk about what you noticed, like how you started the journey of researching the
Yeah.
skin, urolithin A in the skin, and what you looked at, what
Yeah.
changes, like all the measurements that you made.
Yeah, so when we like with nerdy scientists, we said, okay, we need to look at something first. I mean, primary keratinocytes from a healthy donor, like they like treated for 24 hours. We use like urolithin A, like Mitochondrial and Vehicle, and basically assess the impact of the compound on the skin cellular health. And so we analyzed it. We did the analysis of the gene expression changes into this in vitro skin cellular model. And when we looked at them, it was really interesting because we can separate a little bit in terms of extrinsic and intrinsic.
Yeah.
Because in terms of extrinsic, we have seen a reduced gene expression of some really bad protein, like the MMPs, we call them, which is really the promoting collagen breakdowns with skin aging. And with urolithin A different concentration compared to the old donor, the old donor with the vehicle, we had a really decrease of that. So we were so happy to see that. And in terms of inflammation, also interleukin 1, that caused really skin inflammation, that was really decreased with urolithin A. And that was really amazing. And when we look also at mitophagy gene expression of this primary keratinocyte, we saw an increase of this gene expression with urolithin A. So that's where our mind were. And I was like, okay, markers also of improved mitochondrial respiration, all this mitophagy. So it clicks definitely. We said, okay, we have seen that in the muscle. It's just the first study. So now we need to move on and do something. So we also moved before doing all the clinical program. We did 3 more tests on, we call it the RHE. It's the reconstituted human epidermis. It's a 3D model. And we apply UA inside, on top of it. And we saw also similar early activation of mitophagy and autophagy genes
Can you
compared to
say that again? What were you looking at?
the, so it's the 3D reconstructed human epidermis, and you
Oh,
look
the
at,
epidermis. Okay,
yeah, epidermis,
interesting.
and you apply daily UA, and we apply 1% in a moisturizing cream inside. We put the UA compound inside, and we apply on top of it. And so we saw after that on gene expression, early activation of mitophagy and autophagy genes.
Hmm.
And that was observed compared to
Interesting.
the vehicle. So we thought, okay, now, 3D reconstructed human epidermis. Then if we move to another type of cells, fibroblast, human dermal fibroblast, and as similar to the keratinocyte that we did at the beginning, we saw also a reduce of these bad proteins that break down the collagen, the MMPs. So
Hmm.
really we reduce them with UA. And we similar again have the same signature, like increase of mitophagy and autophagy gene expression that
Hmm.
was observed with UA in these cells. And then finally, we took also human dermal fibroblasts, but from young and old. So young, I think, was 23 years old and old was 69. And as expected, from the old donor, we have an impaired basal and maximal cellular respiration. We use an experiment that is a seahorse. And when you use that for a muscle like mouse or human, you use the Ouroboros. And this is a kind of a technique that is quite interesting to measure the respiration of the mitochondria here. And so we have really an impaired basal of maximal respiration in the old donor compared to the young. So UA was really able to rescue both basal and maximal mitochondrial respiration of all the fibroblast cells in a dose-dependent manner. So that was really something when we look at all this preclinical work that we can say on the cells, we were really sure like now to move forwards on our clinical program, definitely.
That is so cool. That's you used a seahorse to
Yeah,
oh, that's fascinating.
I mean,
I wanted let me just underscore before the train leaves the station. You
yeah.
were able to demonstrate in these cell studies that you changed intrinsic and extrinsic favorably.
Yeah.
So both. Cool. Okay.
Exactly. That's the main thing to do. That's
Yeah.
because you can't just look at some protein and since we saw like from this paper before I talked about like Oblong in 2017 that or 2020 they looked at mitochondrial expression and they see these differences. We said we need to repeat that. I mean to see and also with UA always keeping the control and having different concentration of urolithin A and both concentration we saw that. So that was quite amazing to look at.
Incredible.
I mean,
I,
it's science, to
yeah.
look at that and not doing the half job, and
Yes.
be
Yeah.
sure of what you're seeing. And also reproducibility is really something we look around. We're not
Yeah.
just doing one experimentation and say, oh, okay, it's working. No,
You
that's
know, yeah, I know. I just so appreciate it. I appreciate your commitment to the science. I mean, you're elevating the whole field. I think this is really revolutionizing our field. But I just want to go back to this basal and maximal cellular respiration increase in the 69 year
yeah,
old fibroblast and how extraordinary it is. And it just makes me link back to, the paper of sedentary adults and
yeah,
their VO2 max increased, I think on average by 10%. I
yeah.
mean, sedentary adults with only, so they're not exercising. The only intervention is Urolithin A, and you've, increased their ability to utilize oxygen. And I mean, that is mechanistically linked, right? From the micro to macro.
Yeah, exactly. And it's compared to their baseline.
Yeah, that's
Definitely
right.
when
Right.
that's really important when you look at first when they started the trial and after, that's even the best comparison to make. You can have the
Yes.
placebo, but looking at the baseline, I think it's also what you're looking for. If you go into a trial, you want to know if you do the things better.
Yeah.
And yeah, that was an increase, and that was really nice to see that, definitely.
Yeah.
And seeing that in the skin cell, I mean, you're quite happy to see similar signature, all over the organs. And respiration is controversial a little bit because for some people who's doing exercise, they also have like respiration is not changing that much. It's not the parameter that is sure increasing, decreasing. It depends. What is changing a lot is calcium retention capacity,
Oh,
which is
interesting.
changing a lot when you look at aging. And respiration could change sometimes and not. But now, when we looked at the cells here and also with the VO2 max, I mean, there was a clear signature. So that's quite really, I mean, we trust 100% now these compounds and to see the similar signature across different type of cells.
But
That's
you're looking at that calcium retention element as well.
So not on this study, on the future clinical trial that we have ongoing, we will do it because as I mentioned at the beginning, mitochondrial function, there's so many things. There's
Yes,
respiration
yes, yes,
and
yes.
calcium retention by my ex PI who's in Montreal doing that and is really key. And we're doing the clinical trial with them and they're looking at it, and I'm sure it's going to give us like great results. They already started recruiting. They have like 6 patients at the moment. I'm really happy to see that moving forwards. And yeah, that's the main function. Also, one of the main function of mitochondria, definitely.
Oh my goodness. All right. I would love to connect with you when
Yeah, when I have the
those
result,
data come out.
definitely.
Yeah, I would. Well, I mean, maybe we could have like a mitochondrial 101 from I was just I just really appreciate that I'm learning. Okay, so where are we? Do we want to talk about some of the clinical research? Do we want to move into
Yeah.
that, or is there any more preclinical that you wanted to talk about?
No, we stopped at the preclinical at this point, and then I think what is really value our company in terms of research here is when we started the clinical program. I like to call it the clinical program because I remember being in a conference and talking of the first clinical program we had. Like the first test was HRPT. So it's the repeat insult patch testing to test the sensitization and the reaction of the skin with the compounds. And not all the people mentioned it, and I think showing the safety that use compound is safe, can be used at certain concentration. That's the key.
It's like
Before
101.
moving
Yeah.
yeah, before moving forwards on clinical trial, you don't know how people will react. And you can have like after that, like 20, 26 people arriving with like erythema or something. And we don't want that. We don't want like people to have like burn like in the face or like redness and different problem. And I think that's the key when we build up this program, and Dr. Singh really push forwards, and that's something that, yeah, we were so happy when we had the first result. We were like, okay, we're moving forwards, and we're testing on male and females. So that's also something that
You
is
know,
important.
it helps that you're working with a compound that originally came from
Yeah.
pomegranates and some nuts. I mean, there's a safety track record going back like
Yeah.
millennia. So you have that little piece of information, but the fact that you're going through, basically the same kinds of hoops that, we go through for something that's going to be, regulated as a drug is awesome.
Yeah, exactly. And, I think people sometimes taking in like you do the safety at the beginning and said, okay, it's all fine. But no, you don't know how it's going to
Yeah.
be like for different organs. You need
Yeah.
to do some tox study, you need to do some safety study assessment. And by doing the skin, I mean, we, at the beginning in Timeline, we are not like skin experts. We learned every day. We learn every day, and we're still learning a lot. And it's really amazing the way we learn a Timeline on the skin area, definitely. And it's amazing because the science comes first all the time. And by looking at its safety study, when we looked at male and female, it's just not talking about just having females on the skin trial. We
Mm.
had everything like also age from 18 to 64.
Yeah.
And yeah, we applied different concentration, and we saw that over 6 weeks also, it was not just like 24 hours or something. And it was really great, and we had no reaction at all. So it was safe to use, tolerable by people, and that was amazing for us, definitely.
And what did you see? What did you
So,
see?
so after that, so when we had like no problem with the reaction sensitization, we started another trial on the photo damage trial, which was quite interesting because, you want to see how with UVs react. And so we did a trial, I mean, targeting extrinsic aging, as I said, photo damage. And so the skin was irradiated with the minimal erythema dose. And after that, 24 hours after irradiation, we apply immediately. So, sorry, we apply immediately Mitopure cream after irradiation for 24 hours. And what was amazing is like we had Mitopure reduce like the skin redness significantly by 14%. So we were really impressed. And I can tell you, I've seen also kind of in real life, being at conferences, someone coming in at the World Congress of Dermatology. I was in Singapore. She was like, I was really have red face. I was like red thing in my hair, on my face. This is really not nice. I was like, no, no worries. I mean, things happen in your life. And she was like, do you have a cream like that I can apply also that is really good? I've seen that you have anti-inflammatory things, some research I've read about that. And I gave her like some sample of the night serum or day cream. And the day after, she came back, with the little suitcase that they all have in the Dermatology Congress conference to have all the goodies. And she was like, "It works so well. Like, look at my face; it's beautiful." And so she bought so many products after that. But it's when you know the results of this study, and you see also people reacting in really nice way, you understand that it was right. I mean, the 14% that we have seen decreasing the erythema, the redness,
Mhm.
it's just, yeah, it's real also in real life, you know.
Yeah, yeah, yeah. What was the duration of the study?
So it was so after 24 hours, and there was you know, you do exactly the irradiation immediately, so you don't need like to wait too many days, weeks or something. It's just instantly that
Mm-hmm.
you look at the redness.
Mm-hmm.
And so when you apply Mitopur at 1% just after irradiation, for 24 hours after that, you see the decrease. 14% after 24 hours is quite huge. So
Wow.
for us, that was quite key, and it shows also the effect we have on the muscle also, and some CRP decline. You know, so that's one of the best thing of this compound, definitely.
Nice, nice. What else have you looked at clinically?
So we looked after that, we targeted more intrinsic
Mm-hmm.
aging. So we look at Mitopur for different age of people, also by 50 to 75 years old, I think. And for 8 week study, like longer study, we look at CrossFit wrinkles, fine lines. I mean, really visual signs of aging.
Mm-hmm.
And that was really interesting because before and after the day 57, we saw a decrease of wrinkles by 4%. And it was also, the effect was visible after 2 weeks.
Oh,
That was quite
interesting.
amazing.
Wow.
And it was also a split phase study. So
Mm-hmm.
that's what really interesting. It's not just using a product, it was a placebo too. So you look at the face, and the same study also took biopsies.
Mm-hmm.
So what we did with this biopsy was really to look at the inside, and so to look at different pathway, because when you just do the visual sign, you measure the wrinkles with all this experimentation and these tools, which is really nice. But then you want to see the inside, basically what's going on the skin, and so from the biopsy we look at the pathway like collagen. And what was interesting with aging, we saw like collagen fibril organization that was really decreased with aging, but the same pathway was increased with Mitopur. So definitely it was really the
Incredible.
opposite. When you saw the images, like those gene was declining with aging, was like the one of the arms, the other arms of the study, like of the people, they were like using one placebo, one Urolithin A with, I mean, Mitopur. You saw the difference relates really the same gene that was suppressed with aging that was activated with Mitopur. So that was collagen fibril organization and assembly look like give you your skin more firmer and smoother skin,
Yeah.
definitely. So that was quite amazing.
So very exciting. What do you expect for longer term use? So
So
that, yeah.
yeah, so for longer time use, so that's why after that, when we made the product itself,
Mm-hmm.
the finished product, we build a patented ingredient, putting Mitopur with niacinamide and trehalose also together to boost also the finished product, because the cream only with UA and moisture, you need to add also something else. And we did exactly kind of the same study looking at wrinkles, and 8 week study. Similar, we're trying to do the reproducibility of these studies. We looked also the people using the cream actually, and it's really the same, I mean, kind of a word by them saying that the wrinkles improve. You have an hydration when you look at the day cream, the night cream, and the serum. We have kind of the same result for everyone. And this study on the finished product will also do like HRPT study on the safety with if
Mm-hmm.
the formulation was nice or not. And we use also similar men and female
Mm-hmm.
on this study because, as I said, it's not just female, and it's important to look at different ethnicity, different gender, and so
Yes.
between 40 and 65 years old. And so at the end, we saw that Mitopure cream, really the regimen show like a significant decrease in wrinkles and boost skin hydration in like 3 products. So that was really something that we were looking at in terms of skin barrier, elasticity, hydration, all the things that I already mentioned.
Across ethnicities.
Exactly, yeah.
Awesome. That's a huge point.
Yeah.
So how do you have people apply it? How do you recommend applying it based on your literature, like how, or your research?
So we have different type of cream. Definitely, we have a richer cream. We have a light cream that we called before day cream, night cream. But as we also think in this company, all the cream, depending on the season, you can apply that differently. Our night
Mm-hmm.
cream, that is kind of, I can call it now the richer cream, can be also applied during the day,
Mm-hmm.
like if your skin is really dry or something, you need to think how your skin react and what your skin needs. And your skin don't need the same thing during the whole year, depending on the season. What is working really well is like if you apply the serum twice a day,
Okay.
definitely, and using the cream how you want to do. But definitely on this study, we apply the night cream at night and the day cream during the day.
Okay. Okay. Um, what about a body lotion? When is
Ah,
that going to
that's
be in? When is that
that's
going to be in my bathroom?
definitely we have few ideas that's coming really soon, and yeah, I think body lotion is really something that we need to look at because I mean, as I mentioned, skin is the largest organ of your body, so yeah, this is something you need to think of when you do a skincare like regimen. It's not just like the face. Basically, it's the entire body. So yeah, I mean that's something that will come soon, I hope.
Good. Good. Anything else on the horizon for you guys for Urolithin A that you can mention?
I think what we're doing at the moment, we have a few clinical study that's going to start soon. One is going to start really soon. I'm so excited to do that because it's a test clinical trial that will use the richer cream to look at all the anti-wrinkles efficacy, but if also the effect on skin epigenetic, so the bio.
Oh, cool. Oh, cool.
Yeah, and also will input kind of my specialty to look and visualize mitochondria. So we'll take biopsies and look at the morphology of the mitochondria with urolithin A, so with mitopure and without. So that's something that I really want to see. And we have like 12 weeks. It's female and male, like from 50 to 75 years old. So it's going to be really interesting to be able to visualize how your mitochondria look like. And
Cool.
so I think linked to the skin biological age, I think that's going to be quite a really nice study. And for 12 weeks, I think it's really important. We increase also the timing of the duration of the trial that we did before. It was 8 weeks, now with 12 weeks, and we go even deeper. And I think yeah, the biopsy will be essentially on less subject that we have because I mean nobody wants to endure like all the biopsy, but we have like really nice visual to share also with the people because I think it's important to know how your skin look like inside. It could be tricky,
Totally.
but when you saw them, they're really
Yeah.
nice to look at. They're really
Yeah.
nice. So
You're excited.
that's good.
You're in your happy place with that.
Yeah.
Have you recruited yet? Have you started recruiting for
Yeah,
this?
it started. We
And it's
already
under.
have got, yeah, we already got the biopsy. The first biopsy and is going to my
Wow.
lab, my ex lab in Newcastle to do the analysis of the electron microscopy with the electron microscopy in 2D. And I'm blinded. I'm gonna do the analysis. I could tell you like really soon how it looks like. The trial will end up in December, I think, because also we didn't want to do that in summer, due to UV radiation and etc. You don't want to be like, yeah,
Yeah.
people went to holiday and do the trial. You said, "Oh,
Yeah.
no, that's not gonna be good for this trial." So that was the right period to recruit them now and finish beginning of December. So we hope to have a trial soon, and then there's a whole concept of what we have with the nutrition. So to combine some trial with that. So I think it's really a great and exciting journey with us in the skincare kind of area. It's quite new, but I mean, we're moving forward step by step, and I think it's working well because we're completely transparent with everyone. We have published in preprint is under review currently all the trial of the skin, like
Mm-hmm.
the skin trial we have done, including all the cells work, like everything that I've talked about. And no, I think it's quite good that we're moving forward similar to muscle, similar
Yeah.
way.
Yeah. Oh man, I can't wait. I can't wait for the nutrition work. I hopefully we'll be able to participate in some way.
Yeah.
Folks, I want to let you know that Julie has referenced many papers. We're going to corral them together. You will find all of them on the show notes page with the full transcription. This is also going to be on YouTube. And really, this was a great, fun tour de force conversation. You're such a badass scientist. I have to say it.
Uh,
Let me
no.
mention, let me just mention that there's a promo. Everybody, Timeline is offering an amazing promotion. So if you go over to timeline.com right now and use the code KaraSkin, you will get 10% off on your suite of products. And I'm really excited for you to try them. I love them. And, of course, I want to hear from you what you think. Thank you, Julia. That was great.
Thank you.